Okay, here's the demo of 8P. Um, this is a quad tree at just a depth of 2. We can make the depth higher. 2 is pretty good. Your code ought to be able to make it go to 3 or 4, but we won't test it very much there. Each leaf of the quad tree represents an area and is responsible for that area and has an array list in which it stores any of the balls that are in that area at the time. Once the animation starts, as soon as the ball leaves that area, the code that is the thread for the leaf must take that ball out of its array list and feed it back into the tree itself to filter down to find the position it belongs in now that it's moved. Uh, this sleep slider may be useful to help cause some errors. It's how long all of the balls wait between their next update point. This can affect some changes in when we're unsynchronized when things go wrong. The more button puts 40 more balls into the display area. The synchronization button turns synchronization on and off. It starts initially off at off. Start will start the animation and restart, and at the end, in order to close down nicely, we'll have to terminate the threads, and that will have to be implemented by you as well. So we'll just start the animation. This is basically, that didn't take very long at all to crash. Notice down here we get a null language point, null pointer exception, and lots of the colors are no longer changing. Let's restart this and just let the 40 go a little while, because it doesn't, it can go a little while before it starts to break down. Oh, it didn't go long at all this time. Interesting. So you can tell by some of the colors staying constant throughout that they have been lost by their partition, they're not in their correct bunch of gray ones here are clearly just not changing colors. That means the balls in the program. The balls animate themselves. They're not responsible. The quad leaves are not responsible for doing the animation, just for checking the positions. So the balls just merely keep going, bouncing around. So we'll stop that and we'll restart it. And now we'll turn synchronization on and we'll add our 40 more. And now we'll start our animation, and we should be able to go quite a while. We should be able to go as long as you can sit here. I can sit here without any exceptions caused by lack of synchronization. And the colors should keep changing. There's sometimes a delayed update because of the number of items. We should be able to put more balls in the scene. It just slows things down, but other than some balls taking a little longer to change color, they're basically still being kept cleanly by their respective leaves and array lists without any problem. So your job is to implement the quad tree and the placement of the balls into the quad tree and finding their way to the leaf nodes where the actual activity will take place, for turning the leaf nodes into threads. Right now they're just sequential code as delivered to you. And you must turn them into a thread and then implement the various facilities to make sure that they work together, especially the synchronization. This is aimed at synchronizing so that we don't ruin our data structures. Okay, and that seems to be, like I say, when we stop, you need to terminate the threads, and that's the end.